Hello, my name is Electroleum, and today I'm going to be showing you my 2 kilobit or 256 byte storage module. But first, some B-roll. Okay, so the basics of how this works is we've got a bunch of chests here that are just filling this. So each chest represents 4 bits of data because it's being read by a comparator, which can give a value from 0 to 15 in redstone strength. And that's 16 different possible values or 4 bits. And you can see there's just a bunch of stuff in here, and that allows the comparator to read that signal and store the data. Each column is selected using a row of pistons. So you can see this comes down and then just selects it. So when the piston comes down from the row select, it will put this value onto the bus, as it's called, and then that signal, wherever it's at, will be brought all the way to this row of comparators, which you can see is all the way from there to there. And then we also have the column select, which is each of these pistons, and that when it goes down will select this and go out here. So I can show you an example right now. So you can, if I come all the way down here, we can see that this chest, which has 4 stacks in it, is giving out a value, and then this one was selected by row select, so you can see everyone in this row is selected. So it's outputting that onto the bus there, and then I'll just use this one example there as well. So if we come down to the end real quick, we can see that these two, so it comes all the way down there and there. But the only one being put on the bus is this one, because that piston is lowered, and so it puts this value onto the main bus, which comes out over here all the way to this decoder, which was designed by Melark. I'll put a link to that video in the description. It's really cool, and this is not something I would be able to do easily, so props to him. So it takes that analog signal and then converts it into the 4 binary values, which get sent along the bus all the way over here to the output. And there are 2 layers of this storage module, because there's 4 bits in each layer, and they're identical and then connected with glowstone so that the address lines are the same. And this is all cool, but you may be wondering how we get just this piston activated and not the rest of them, because if you have more than one down at the same time, it'll cause congestion and corruption of data. So that's what this is for. So it will take the signal in. So right now you can see it's like this. So you set whatever address you want. So let's say, I don't know, address 17. We'll pick 17. Then you load it in using this button. There we go. So it's loaded in, and you can see it's picked its values, and it's outputting them. But what this does is it takes each of the 4 lines and splits them into two groups. So you can see we have the lower 4 bits go to this upper panel, then the higher 4 bits go to this lower panel. Yes, that is reversed. I don't care, but yeah. And then you can see these red lines are just the inverses of the green lines. And what this does is it acts as a sort of quad AND gate. So what this is detecting is turn that redstone torch on if all 4 of these are off, but one of them is on, so it's not. And then this is, so that'd be 0001, and then this is 000. Wait, sorry. This would be 0000, and then this one would be 0001. This third one would be 0010, because this is the 2 spot, so it's like 1s, 2s, 4s, 8s. And then it does that for every single one, and you end up with only one line turned on how it's selected. So in this case it's line 2, which would be in computer terms line 1, because it starts from 0. So it's 0, 1, all the way down to 15. Now the bottom layer, while it's the same thing, looks a lot more impressive, because you've got the same system of AND gates. So at the end it's 1 1 1 1 1 1 1, and then 1 1 1 0, and then 1 1 0 1. And yeah, so far down all this line. But the cool part about this is that all these bus lines get wrapped around to their corresponding piston over here for the column select into these glowstone towers, which power both layers at the same time. But I just like the look of it because it's so long. And yeah, that's the basics of it. Right now it's programmed in as a sort of multiplication table, so I can show you something. So if we go to like address 0, it should output, actually no, let's be crazy and go to address, I don't know, what's that, 18? So I believe that should be an output of 2. So if I load this in here, this is just a D-type register. I don't remember who made this, but I'll link their video in the description as well. But yeah, the entire memory module is made by me, but the decoder and the register are ideas that I use. So here it's outputting 6 and 6, but that's just how I programmed it, because the original was 4 bits. So it's just 0 1 1 0 0 1 1 0. So yeah, if you have any questions or comments, put them down below. And yeah, I plan to make more updates about this in the future, because I'll be trying to shrink this down. As you can see, there's space in here which I can cut out to make this more compact and easier to build. And then I'm hoping to try and get these memory modules aligned, because you can see there's a space in here. If I can try and eliminate some of this space, that'll help tremendously with the size, because right now it's getting close to impractical size. But yes, I'm also working on a adder, which you can see over there, but I'll have videos out about those soon, and I hope you enjoyed.